Hey guys, welcome back in a new video about the piecewise function. Uh, so this problem, it said find the indicated value of f okay, so that's the first thing he's asking us, and then graph and label the function. So B wants to graph and label, okay, the point from bar to A, and C wants to find the domain and the range and the values of x in the domain okay of f at which x f is discontinuous. Okay, so that's the three thing he's asking us to get in the problem. So we're gonna go over the first problem, the function f negative 2, f1, and f2, and the function itself f of x is equal x okay let's okay, f of x is equal, this piecewise function is two expression. That's why they call it piecewise. So it's more than one expression. And the first expression is when if x greater than or equal negative 2 and less than 1. And if x greater than or equal 1 and less than or equal 2, then the function is negative x plus 2. Okay? So if x greater than or equal negative 2 and less than 1, and minus x plus 2 if x greater than 1 and less than 2. So for this function here, piecewise function, we call it piecewise function because it has two expression, sometimes three, and we want to find the value for the 3 point, where they're gonna fall basically in this, in which function each of this point will fall. And we get the value, and once we get the value, then we're gonna graph it, and then when we after we graph it, then we're gonna get the domain, which is basically the x value, and then we get the range, which is the y value, and then we get the discontinuous, where the function is discontinuous, it's not a straight line, and we're gonna exclude this from our domain. Okay, so that's the plan for this problem here. Okay, let's start. So we're gonna start with first thing, just finding the value for the function at those points he's mentioned. All right, so first one, when we say f of negative 2, okay, where is the negative 2? So if we look at the function here, so negative 2 is right here, it's in the first one. So this is x greater than or equal to negative 2 is equal x, right? So f is equal x, which is equal to -2. So the first one, f of -2 equal x, which is -2. So my first point is -2 and -2. The x and the y. Okay, the second point, f of 1. Okay, f of 1, if we look here, the second expression, x is greater than or equal to 1. So we say f of 1 is equal -x plus 2, and then we substitute for f of 1, so it will be -1 plus 2, which is equal 1. So f of 1 is equal 1. So my second point is 1 and 1. All right, and then the third point, f of 2, so the same thing. So f of 2 is equal to the second expression and the function here, -x plus 2, so equal -2 plus 2, which is equal 0. So f of 2 equals 0, so the third point will be 2 and 0. All right, so we have the 3 point, 1, 2, 3. Okay? Okay, now we want to graph this. That's the second step. So we do x and y axis. So that's x, that's y. 1, 2, 3, 4. 4. 1, 2, 3, 4. Okay, first point, -2 and -2. So it's right here. And we can make, so the function is defined at -2 and 2. It's continuous, so we can make a solid point here. All right, the second is 1 and 1. So 1 and 1. So this is -2, -2. This is 1 and 1. And the third is 2 and 0. 2 and 0 right here. So the all solid point. Why? Because they have, it's the function is known at this point. Like we say, x at -2, right? It's continuous. And then x is 1 at 1, and then x at 2. All right? So we're going to graph this point. And that's my function here. All right? Now we're going to see what the third, it said once the domain, the range, and the value when x is not discontinuous. Right? So the domain, it's going to be from -2, that's x. Domain is basically the x value. So what the x value? So we say here from -2 to 1, that's all continuous. So we're going to make a closed parentheses like that, -2. So basically it's from -2 to 2, because all these values are continuous, right? So that's my domain. The range, which basically the y value, it's same from -2 to 1. right? And we can say the function is continuous on its domain. Why? Because it's all solid point here. It has a y value for each x value here. Like you say, x at 2, it's equal to, there's a continuous function here. Okay? So that's the first problem. Let's have another one, similar one. Okay, it said the value f, -2, f2, and f5. Now that's a three indicated value he wants us to find. And what is the actual function? So we're going to follow exactly the same thing here. So we're going to find the indicated value, graph, and then find the domain, the range, and where is the discontinuous x value, or where the function is discontinuous at. All right. So the function f of x is equal 1 x greater than or equal -2 and less than 2, and -3 f x is greater than 2 and less than or equal 5. Okay, so that's my two expression for that piecewise function. So I want to find function -2, 2, and 5. And then for f of x, when x greater than -2, less than 2, the value is 1. And when x is greater than 2 and less than 5, the value is f of x is -3. Okay, we're going to follow the same steps like we did at the first problem. Okay. So what's the first thing we do? We get the value. So for f of -2, right here, check the first one. We know already. When x is -2, equal 1. So this is known because x is greater than or equal to -2. All right. The second one. So the first point is -2 and 1. All right. So when f is 2, let's see that one. So when f of 2 is not included in my intervals here, so that seems like it's undefined, is not defined. All right, so it's gonna be basically a hole where this is where is the function is discontinuous. And then the third value is f of 5. Check here, so is equal to -3. So it will be 5 and -3. Okay, let's graph the function. Okay, -2 -2 and 1. So that's solid point, right? Okay, and then we have the 2 line. So we can just make like imaginary number here, imaginary line. All right. So that's -2 and 1. then at 2, the y value is undefined. Okay, and then the second point is 5 and negative 3. So 4, 5, and negative 3. That's known. Right? So if we check here, so here is function is undefined, but here is defined. That's why you have solid point. Okay, so at 2, when x equal 2, the y value is undefined. So we draw a straight vertical line. And we have a value for x equal negative 2 and x equal 5. Okay? So now let's write what is the domain. So the domain, basically it will be, here we say this is negative 2 and 1, and this is 5 and negative 3, and this is 2 here. Okay, so domain is going to be negative 2 and 2. 2 is going to be open, this is closed, right, because it's undefined. Union 2 is going to be open again, and then 5 closed. So that's my domain. And then my range, okay, basically it's a set of from negative 3 to 1, except the function is discontinuous at x equal 2. Okay? So that's the second problem. Let's have one more. Okay, the third one okay, this one has three expression. We're gonna exactly find the same stuff. So wants to find f negative 3, f negative 2, and f 1 and f 3. And my function has 3 expression. So 4x plus 11, that's if x is less than negative 2. And then 3, if x is greater than negative 2 and less than negative 1. And then negative 1/2 x plus 7/2 if x greater than 1. Okay, so we have 3 expression in this problem here. So we're going to follow exactly the same steps we follow in here. So we're going to find, define the value for the function at this 4 point he selected. Okay. So the first one is f minus f equal -3. So that's going to fall in the first expression, because we said here x is less than -2. -3 is less than -2. So we're going to follow this. So we're going to say f at -3 equal 4x plus 11, and then equal 4 -3 plus 11, which is equal -12 plus 11, which is equal -1. So my first point is -3 and 1. Okay, and f of -2 equal, okay, so we have the -2, we have it defined here. So f of -2 is, there is the y value, 3. Okay, and then f of 1, the same thing. F of 1 has a value of 3, and then f of 3 is greater than 1, so it's going to follow here, is equal to -1/2 x, don't forget the negative sign, plus 7/2. So it will be equal -1/2 x is 3 plus 7/2, which is equal -3/2 plus 7/2. So that's 4/2, which is 2. So the point is 3 and 2. Already? So we have the value here. That's 4 point. And 1 and 3. Already. Now let's graph the function. Okay. Some technical difficulty here. Okay. Okay, good. Let's graph the function. Okay, first point, -3 and -1. So -3 and -1. So, but don't forget, this point is not defined. Function is not defined at this point. It's not included. So we're gonna just, we're not supposed to make a solid point. So, but we're just gonna know that the point is here. Okay. And the second, -2 and 3. So -2 and 3, it's right here. This is -2 and 3, that's point. And then 1 and 3, it's here. So this a solid point. And then from 3 and 2. So 3 and 2. Right? 1, 2. It's right here. So I'm just going to make a point here. So then, so if we check the value here, it said x is less than -2. So this basically is going to be arrow. And then x is greater than 1 at this point. So it's going to be, this is x, this is y. Arrow here, right? Okay, so here it's basically going to infinity, and here is going to a -infinity, and here is going to -infinity, and my the function is basically the y, the range is this 3 here, right? Let's write down. So So the function is here, greater than -1. So we can add, this is basically, that's a function, -1/2 x plus 7/2. And this section is 4x plus 11. And here is basically the 3. Okay? So let's write down the range and the domain. Okay, so we use a solid dot at -2 and 3, basically to say that the function y equal 4x plus 11 and y equals 3 agree at this, at x equal -2. And the same thing. We use a solid dot here to say the function -1/2 x agree at this point. So these two function, they agree at this 2 point. That's why we have a solid point. Okay? So the domain, it will be, start from the left here, -infinity to 2. Okay? To -2. So the 2, it's going to be included in both functions. It's going to be open with the -infinity and close with the function in -2 and 1. All right? This is close because it has value. So union -2 and 1, union 1 infinity. So basically, see, infinity, -infinity is going to be -infinity to infinity, right? And then the range, so that's y value. So it will be -infinity to 3, because 3, that's the maximum value for y. And the function is increasing from -infinity, increasing from -infinity, -2, and then constant from -2 to 1. It's like flat line, right? And decreasing from 1 to infinity. All right, from 1 to infinity is decreasing. All right, and from here, -infinity to 2, it's increasing, and then constant from -2 to 1, and then decreasing from 1 to infinity. Okay? So this graph, we have no breaks here, so we can call this graph, it's a continuous. If it has no any breaks or gaps, right? And that's it. There you have it. That's a good example of piecewise function. So if you like the video, please like and share and subscribe for the channel. Thank you very much, guys, and I'll see you in next video.